Welcome. How's NDC going for you all? Yeah? A few nods. Is there anyone that's willing to say no? No? Everyone's having a good time. That's good. Hi, everybody. I'm Ankur Kotwal. I'm a developer advocate on the Google Cloud Developer Relations team. And today I have what I think is a pretty fun talk. I'm a little bit biased for you. We're going to look at how to build an application that runs
the mic's off. To turn it back on
a real Google Home. And I'm going to show you how we do it using .NET containers on the Google Cloud. So before I get started, I want to get a quick sense of the type of audience that we have here. How many of you identify as DevOps people? DevOps folks? Nobody here? Okay. How many of you identify as developers that do a fair bit of coding? Just about everyone. That's awesome. How many of you are using languages other than .NET, like the .NET languages, or primarily C#? Is everyone here a C# developer? Everyone? Yes? Okay, cool. And how many of you, if you can raise your hand, deploy your applications on your own data centers, your organization's own data centers on-prem? Yeah, a few. Does that mean that the rest of you are either hybrid or like fully on someone's cloud, like Microsoft Azure, Microsoft AWS, or Google Cloud? Okay, cool. So we got a bit of a split, which is good. So today, what I wanted to show you was how we build this application, and I'm going to do it by starting straight away with a demo. What I do also want to set the expectation is that everything you see today is an open source project that you can download off GitHub. I have saved the URL to the end, so you have to stay for it. No, I've given you my Twitter details. If for whatever reason you need to leave, I'm happy to share that URL with you later. All right, so I'm gonna just unmute my mic.
The mic's back on.
Okay, Google, talk to my test app.
Okay, let's get the test version of my test app.
Good day, fellow developers.
Say hi to everyone.
Hello, NDC. Great to be here today.
I want to search for temperatures.
Okay, you can ask BigQuery about top hacker news or global temperatures on a certain day.
What was the hottest day in Australia in 2017?
Scan 5,272 megabytes in 4.0 seconds. The hottest temperature in Australia in the year 2017 was 44.9 degrees Celsius at the Ivanhoe Aerodrome AWS monitoring station.
What was the coldest day in 2016?
What is the country?
New Zealand.
Scan 5,272 megabytes in 3.3 seconds. The coldest temperature in New Zealand in the year 2016 was minus 2.5 degrees Celsius at the Waiouru Airstrip monitoring station.
So, I wanted to say that some of the delay there is because I'm using a wireless hotspot. Getting connectivity with conference Wi-Fi is a little bit more challenging. But more interestingly, what you'll see there is that we have an app that's running that we've deployed. Now you may say, hey, this is just regular Google Home. You can ask these sorts of queries to Google Home. I can assure you that the queries that we're doing today are using entirely our application. And it's actually a .NET container that we're running on the Google Cloud platform. There was a little bit of gloating there from the app. It was telling us how many megabytes it scanned in how many seconds. And that information is really only here for like developer purposes. I'm going to address that in a little while when we get to the relevant slide. But the point is, we're going to look at what it takes to build something like this on Google Cloud. And the first place I wanted to start off was talking about containers. Now, as you start to shift your workloads onto a cloud, typically most people default to thinking about virtual machines. And virtual machines are great because we have a highly configurable environment. If you look at it on the left-hand side, it's something where you can customize it to your needs. You can set up your images based on whatever software you need, and you can set up sort of sandboxing and networking between those virtual machines. With the cloud platform, we also have a feature called the Cloud Marketplace, where you can get predetermined solutions that other people have configured, pre-configured at VMs, so that you can get straight away a web server with a database VM pre-configured and set up to talk to each other. But one of the downsides to VMs is that they're heavy, right? When you think about a virtual machine, you're kind of emulating the whole environment. You're emulating a CPU, memory, graphics stack, network stack, disks, and so on. And there may be some of you in the room that say, oh, VMs aren't exactly emulation. You're right, we're not on x86, we're not necessarily emulating x86 architecture, but just for the sake of brevity here, you can think of it like emulation. We're treating it like a whole machine. So as you start to have more and more VMs, you tend to sort of give away some resources to managing, to running multiple VMs. Now, if you're using a cloud, doesn't matter whether it's Google, Microsoft, or Amazon, it doesn't really matter how many VMs you have. You pay a certain cost for those. But wouldn't it be great if we could get the sort of same benefits that we tend to have with VMs and sandboxing, but in a lighter way? Well, Docker solved that for us with containers, right? And Docker containers have now become a standard format for all of us to ship software. Well, not for all of us. I think it's certainly very popular right now. Not everybody's doing it yet. But I expect that more and more we're going to start to see people deploying containers on cloud. Now, with the Google Cloud Platform, there's basically two ways that you can deploy your containers. One is through our product called Kubernetes Engine, and another is through Google App Engine. Kubernetes Engine is basically our managed Kubernetes service. So if you've not heard of Kubernetes before, it's an open source platform that basically allows you to treat your applications as applications, not as machine. You can kind of start to disassociate the infrastructure side of things. And what happened is that for over a decade, Google has been running its services on an internal product called Borg, which basically is the same concept of containers. And we've been doing that for a long time, even for our internal builds, as well as for our actual products. And Borg allowed us to, because we'd containerized all of our services, it allowed us to scale up and down based on user requests, user needs. And it would do it automatically. So what we decided to do was take all of these sort of internal bits and pieces and turn it into a full-blown open source product that we called Kubernetes. And we launched Kubernetes roughly 4 years ago, maybe a little bit more than 4 years ago. And its adoption has really taken off, to the point now where you have managed Kubernetes services provided by all the big cloud providers, Google included. Now, Google actually, oops, I'll get to that in a second. Google's managed Kubernetes service is called Google Kubernetes Engine. And if you want to know what the difference between sort of Kubernetes and Docker is, you can think of Docker as a container format. Kubernetes actually goes and orchestrates multiple containers. So imagine you've got a bunch of containers that need to come up and there's dependencies between your clusters of containers. Kubernetes makes it easy for you to be able to handle those dependencies. You can have a load balancer, a bunch of web front ends, maybe a few database instances, and so on. And you can set those to auto scale. Now remember I said there's Kubernetes Engine, which is our managed service, and I also said that there's App Engine. App Engine Flex, in particular, is a way for you to, again, host Docker containers, but where this time you don't need to go into the finer details that you do with Kubernetes. With Kubernetes, you have very explicit controls about how you want to scale your application. With App Engine, give it a container image and just let it scale for you. That's the promise of App Engine Flex. We also have a different version of App Engine called Standard, and that's a much more tighter sandboxed environment with very specific versions of languages that we support. We're not going to talk about that today. In fact, the application that we are using today is running on App Engine Flex. But the reason that I wanted to show you what Kubernetes Engine was is because the source code, when you download it, you can choose whether you want to host it on Google Kubernetes Engine or on App Engine. They are interchangeable for this particular demo that we're doing. So going back to our diagram here, we've got our highly customizable world here. We've got our container world here. When we look at something like building container images, we also offer a product called Cloud Build, which can integrate with your source control systems so that you can kick off a build and generate a container image. Once that build is complete, it can then publish that container image to a container registry, which by the way can be private to you. It doesn't mean it has to be public. And then once you've got your container images in your container registry, you can deploy them to whichever of the services that you want. You can do rolling updates and so on. Now, in this new world that we're starting to get towards, we've probably heard of the term serverless. We now have a product called Cloud Functions. And with Cloud Functions, you can write bite-sized pieces of code, think of them as components of your application, and they will be triggered when specific events are fired, and you declare those events. So an example of something that you might want to do is if you have a product that has users uploading user-generated content, let's say you have images that users are uploading, when a new image is uploaded to your storage bucket, you might want to go and generate thumbnails of different sizes for those images, so that when you serve them to your users, those thumbnails are pre-generated. That's a great use case for a Cloud Function. Now, if we turn this diagram around a little bit, you can think of Cloud Functions being the most managed version of all of this as a serverless platform for event-based microservices. App Engine will, as I said, you just give it your container image, we'll scale it for you. With Kubernetes, Kubernetes Engine, we give you a bit more control over how you want to scale those things. And with Compute Engine, that's where we host your VMs. Now, as you look up and down this stack, what you start to realize is that, yes, this side is a lot more configurable, but there is a lot more responsibility on the developer or on the DevOps folks, because you need to make sure that the versions of the operating system that you're running here or any supporting services are running the latest versions from a security standpoint, right? You need to make sure you're the one that's sort of tracking those patches and so on. And Google has a number of services that will alert you saying, hey, you're running a version of a web server in your image that is known to have some security holes and so on. But the point is that it's your responsibility down here. As you start to move up this stack, we do more of that management for you. As if you're deploying an App Engine, we'll go ahead and apply patches for you on a weekly basis, because it's just your code that you're having to manage there. So if we think about what our app is today, it's just an ASP.NET Core app written in C#. I'm just going to show you, whoops, before I go there, I'm just going to show you what the project looks like. So on the right-hand side, can everybody see that clearly? You don't need to be able to read the text, but as long as you can see VS Code, you can see this is just a standard C# project. We've got a bunch of C# files in there. We also have a Docker file that tells us how to run this container image, what to do with it. And then we have this app YAML file here that tells us that this is an App Engine application, and that we want the flexible server environment. So this mostly should feel familiar to you. Now, one thing that's happened over the last few years is this explosion in interest for machine learning. Machine learning has been around for quite some time, but it's only over the last few years that it's sort of transitioned from being useful in academia to real-world products, to be relevant to consumers. So an example is, anyone have a Gmail account? Yep, many of you, that's great. Gmail's spam filters are actually built on our machine learning technology. So we have pre-trained models that we deploy to detect spam. Now, even though they're pre-trained, what we do is we also look out for further signals to continue to improve those models. So if you happen to get a spam mail that, for whatever reason, those spam filters didn't detect, and you mark it as spam, it's actually going to update that model so that next time it'll do a better job of categorizing something as spam or not spam. Google Photos is another product that, to me, I find incredibly useful. So I upload all my photos to Google Photos. And if you do the same, one thing that you can try on your own is go into the search box and type in the word cars. And suddenly Google Photos will return to you all the images that have cars in them. You can do this for dogs. It can even group photos by faces. And in fact, if you go and type in Big Ben, and you happen to be in London and taken photos of Big Ben, it will return those, regardless of whether you've got GPS information on those photos. Because Google Photos uses an ML model that is able to detect objects. It's able to detect things like cars. It's able to detect landmarks like the Big Ben. So machine learning is really, really changing the way that we solve problems and the types of problems that we can now solve for our users. Now, if you're looking to deploy your own ML or looking to apply some ML in your products, you've effectively got two ways that you can do it. You can use a pre-trained model that's made available to you, or you can go ahead and create your own custom model and then serve that. Today, we're going to look at the pre-trained models. On the cloud platform, we have many ways that you can go ahead and deploy and train your own models as well. But for this specific example, we're going to look at pre-trained models. And the way that Google Cloud makes these pre-trained models available to you is just with standard APIs. So the Translate API will translate between languages for you. The Speech API will convert spoken word to text. And in reverse, it can take written words or text and say it naturally out as speech. Now, if you think of a product like Google Home, that's exactly what it's doing. It's relying on this sort of technology. But it's not enough just to convert speech to words. You need to be able to extract meaning out of them. And that's where the natural language APIs come in. Because when a user asks for something, even if we have the text, we need to be able to understand what is it that they're asking for, what is their intent. And that's something we're about to have a look at with our application. The video intelligence APIs allow you to detect objects and transcribe videos along with annotations of timestamps. So you can jump to that exact point in a video where something was said. The Vision API is actually a version of Google Photos. It's similar to how Google Photos works, where you can throw an image at the Vision API and it can go ahead and identify labels for you. It can identify landmarks, it can identify faces, and even tell you what is the emotion that the person, that particular face has. Are they happy, are they sad, and so on. And then we have the Cloud Jobs API, which also helps you actually match people's skill sets to jobs that might be like actual employment that might be available. So let's look at another demo. This one's going to use the Vision API. So I'm just going to refresh this. This is just like a debug window into our backend.
The mic's back on.
Okay, Google, talk to my test app.
Okay, let's get the test version of my test app.
Good day, fellow developers.
Let's use the Vision API.
Okay, you can ask Vision API to search for images first. What do you want to search for?
Pictures of Sydney.
Found some pictures of Sydney. Now, select a picture.
Select the first picture.
Picture 1 selected. You can describe, show landmarks, or ask whether the image is safe.
Describe the picture.
This picture is labeled aerial photography, waterway, bird's eye view, water resources, city, and coastal and oceanic landforms.
Search for pictures of Paris.
Found some pictures of Paris. Now, select a picture.
Select picture 4.
What is the index?
4.
Picture 4 selected. You can describe, show landmarks, or ask whether the image is safe.
Show landmarks.
This picture contains Eiffel Tower.
Search for pictures of planes.
Found some pictures of planes. Now, select a picture.
Select the second picture.
Picture 2 selected. You can describe, show landmarks, or ask whether the image is safe.
Is the image safe?
Let's see. This picture is fine.
Exit.
The
All right.
mic's off.
So we saw a number of things happen there. And I'm going to describe each of those with a slide. If we now look at our app diagram, what we've done is we've added some data sources. So what our application is actually doing is querying Google search for that first set of pictures. So when we say, show me pictures of Sydney or Paris or planes, we're just fetching some images from Google search. There's no real intelligence happening there. But when we then say describe the picture, and we asked it to describe Sydney, that image of Sydney, we actually sent that image to the Vision API. It didn't know that it was coming through Google search or anything like that. We're just sending it an image. And in that Sydney image, it detected that this was aerial photography. It detected that there was a city there. It said that there were waterways there. When it came to Paris, for us, it was clearly the Eiffel Tower. And when we said, show me landmarks, it detected that. And then the third thing we did was look for pictures of planes. And it was a movie poster of a kid's movie. And we said, is this a safe image? So one of the things that our Vision API and our Video Intelligence APIs support is explicit content detection. Turns out that on the internet, if you give the people the ability to upload user-generated content, you're going to get a lot of explicit stuff. These sorts of capabilities can make it easy for you to sort of identify those and action them accordingly. But the point is, like, we've done something fairly sophisticated there of using the Vision API to really do things that I think we wouldn't traditionally think that would be possible to do. If you imagine writing some code to be able to detect objects in an image, it's an insurmountable task. But because the Vision API is a pre-trained model that we just expose as an API, as a REST endpoint, we make it very easy to do so. Now, I did say REST endpoint. We are in the C# world here. We actually have a client library for C#. So we make this very, very easy to do. So if I say, go to our handler that deals with, let me see if I can make that a little bit bigger. Is that better? So if I go to our handler class, we have this Vision describe handler. And I want you to also just keep this in mind. It's not important right now, but we have this intent, vision.describe. That annotation is telling this class to handle description of, describing images. We basically get into this method called handle async. And if you look at the code that we have to describe an image, it's pretty simple. We create a Vision API client, then we tell the client, go ahead and find out the labels for me. So when we say describe an image, we're saying what are the things that you see here. Literally, it's a single API call and we pass in our image, and then we just get the labels back as a list. It's as straightforward as that. And then in terms of our response for the handle async method, we just combine that list and we give back those, in this case it was aerial view, city, waterways, and so on and so forth. When we look at the landmarks code, again, it's similar. We have an intent for vision.landmarks, and in our handle async method, we're getting a Vision API client. We're telling it, go ahead and tell me what landmarks are in here, grabbing those landmarks and just returning them as a list of strings. Really simple, but it's actually quite sophisticated in terms of what it's accomplishing. So, going to switch back to this. So now in our application, we have one data source, right? We're getting images and we're able to do some vision. Let's expand that a little bit. Let's add a second data source, and we're going to use some big data here. Now, I gave a little bit of this away with that first demo that I gave when I asked for temperatures of in various countries, hottest and coldest temperatures at different years. That whole thing was based on a product we called BigQuery. Now, BigQuery is a petabyte scale database. It crunches through terabytes of data incredibly quickly. So in the case of the weather, remember I said earlier the application sounded like it was gloating a little bit? It basically did about 5.2 gigabytes of data in 3 seconds. And that's what it was telling us. So with BigQuery, it's a NoSQL database. You can host your own data on there, obviously. You don't need to worry about scaling it. So the point is you put your data on there, and when you send out a query, BigQuery, being a managed service, will work out how many servers it needs to farm it to, and it'll basically bring that full power of sort of Google's infrastructure to serve your needs. So you can get through tons and tons of data. BigQuery powers many of our own products, actually. So I want to show you a couple of demos of that capability.
The mic's back on.
Okay, Google, talk to my test app.
Sure. Here's the test version of my test app.
Good day, fellow developers.
I want to search for news.
Okay, you can ask BigQuery about top hacker news or global temperatures on a certain day.
What was the top Hacker News post on April 20th?
Sorry, there is no data for that date.
What is the top Hacker News post for April 20th, 2018?
Scanned 698 megabytes in 5.1 seconds. The top title on Hacker News was titled, SmugMug Acquires Flickr.
Okay, so
The mic's off.
back to our debug screen. I should have had this up earlier, but the point was that it detected my query. In our backend, which we're about to have a look at, it then generated a SQL statement for BigQuery, and then we got our response. It basically, in this case, it was only a 700 megabyte database. This is the Hacker News database. And we got the top 10 results. We only spoke the first one. So with BigQuery, I mentioned you can host your own data, but we actually publish a number of public data sets. Hacker News is one of them. We have Reddit as well. They're regularly updated. There was the temperatures database. I believe we've got information around taxi usage in New York. And so people have taken that information and tried to predict the supply and demand of taxis at various times of the day in New York and through different times of the year as well. So it's really, really interesting, but the point is that we can crunch through a ton of data relatively quickly. Now, if we have a look at how some of this stuff works, we're now going to the BigQuery.HackerNews intent, and then, in our handle async method, we basically first extract the date that's passed to us because the user said, hey, give me a top Hacker News post for a given date. So we get that parameter out. We create a BigQuery API client, create our SQL statement, and pass in our BigQuery parameter just down here. We actually start a stopwatch so that we're able to tell how long BigQuery takes to handle this request. And then towards the end, once we get our data back, we just set our fulfillment text and return the titles. And that's what gets spoken out. So now, in our application, we have two data sources. But there's a crucial piece of our application that's missing. Because so far, this is just a fairly traditional backend. And that piece of, that component there is the conversational UI. I've been talking to my application this whole time using my voice, whereas this thing has just been handling some intents, right? It's already got some really nice data that comes to it, a formatted date, and so on. So how does that work? Well, for that, we have a product called Dialogflow. Now, Dialogflow is the place that you can go to create conversational user interfaces across many, many different platforms. This is not exclusive to Google's platforms. You can create Slack bots if you want, and I guess you can create any sort of conversational interface that you want for just about any platform you can think of. Dialogflow is supported across all the popular devices and platforms at the moment, and has global reach. So you can actually localize your responses to be in languages wherever your users are. Now, I've talked about Google Home today so far, but realistically, under the hood, it's actually a product called Google Assistant. So you can think of Google Home as a smart speaker that speaks to Google Assistant. Now, if any of you have an Android phone, you have Google Assistant built in. You can make Google Assistant queries. For those of you with iOS devices, if you use the Google app and you hit the microphone, you're talking to Google Assistant. Google Assistant is also available on smartwatches, on Wear OS watches, on Android TVs. It's coming to sound bars. Even cameras, Nest's IQ cameras have Google Assistant built in. So for developers, when you build for the Google Home, you're not actually building for Google Home, you're building for Google Assistant. And the developer platform for Google Assistant is something called Actions on Google. Now, I know I'm throwing a few product names at you. Dialogflow is the thing that abstracts all of that detail for you. Build it on Dialogflow, and then that way you can support Actions on Google or any other really popular conversational platform as well. And that's what we've done. Our application is actually built using Dialogflow. Now, Google Home is doing the smarts for us of taking what I'm saying and transcribing it to text. But Dialogflow is really the thing that's using machine learning to take that text and understand what it is I'm after. What is my intent? What is the user really asking for here? So in the case of something like this, book a flight from Los Angeles to Hawaii for less than $300. Like we've obviously got source and destination. We've got some limits on the spend, and the book a flight is the actual action that's being taken. So Dialogflow is able to split all that up and then call our application. I'm going to show you how that works in a minute. So if we have a look at our sort of our diagram of how this works, somebody like a human is talking to one of these surfaces, whether it's home, phones, TVs, smart displays, whatever. That all goes to Google Assistant, and Dialogflow manages that conversational piece. So let me just show you what Dialogflow looks like. I'm going to full screen, this. All right, so this is the Dialogflow console. And for some reason, is that better? Okay, so I know this looks like there's a ton of stuff here, and yes, there's a lot that we can do. But in terms of our application, what I want you to think of it as some intents that we have to sort out. So basically in intents, you'll see a list of the types of activities that a user can carry out. And if you look at those first three, it's BigQuery, right? We've got this middle one here is BigQuery.intro, which basically says when the user says, I want to search for news or temperatures, or I want to use the BigQuery API, go fire up that intent. So I'm just going to show you what this intent looks like, because you can build your Dialogflow application entirely in this user interface, and it's actually very, very simple and straightforward. So you'll notice that we've got this section here, training phrases. In order for this intent to be fired off, one of these training phases has to be mentioned. I want to search for temperatures, news, BigQuery API, or just BigQuery. And the cool thing about these training phrases is that even though we've put in multiple ways for the user to say this, Dialogflow and Google Assistant are smart enough to match to these things, even if you don't say it explicitly. So if I just said the word temperatures, it'd probably get it, because there's nothing else in my application that is a close match. I don't have to use those exact same words. And if you think about the way humans talk to each other, if you tell me a story today and I recant that story to someone else tomorrow, I'm not going to deliver it in exactly the same way you did. We all have our own way of speaking. And that's really where we're getting to with conversational flows, where we're able to use machine learning to really understand what it is that the user is saying, what is their intent, and then we're able to match it. So if I go back to intents again and I look at Hacker News, we've got some phrases that say something like, well, what was on Hacker News yesterday, or what was the top Hacker News yesterday, what was the most popular Hacker News article on a given date. So already you can see that it's highlighted these fields, which are really date fields. And so if we scroll further down, you'll see that there's a parameter date. And so what happens there is that it's going to match what's being spoken, and it's going to put in a date field into the request that it sends our application. But it goes further than that, where when it finds words like yesterday, it's actually going to change it to a sys date. So it's going to give us a proper date. So our application doesn't need to be smart enough to be able to tell the difference between yesterday or last week or last year. All we get is a properly formatted date that we can go and throw in that BigQuery or whatever it is that we're going to do. So back to the intents. I'm just going to unfull screen that. Oops. The Wi-Fi up. Now, remember in the code earlier I said, hey, we've got these intents? Well, that's what I was getting at. So this was the Hacker News handler on the right-hand side. And I said at the top of the class, we have an annotation that says BigQuery.HackerNews. Those intents map to an intent in Dialogflow. That's all the linkage that you need. So set up your intents in Dialogflow, extract out the parameters, and then on the back end, all you need to do is annotate your class and pull out, in our case, we pulled out the date field for Hacker News. Switching back to something like vision, when we said is something safe, we had an intent vision.safe, and again, we were able to, from the conversation state, we were able to pull out the URL of the image and tell the vision client, is this thing a safe image, or is it explicit? So like matching those things is actually relatively easy to do. Okay. So if I now look at our diagram, we've now got this side of the world where we've got the conversational UI. But if we actually have a look at where our code lives, it lives in Dialogflow, and it lives here, which it calls BigQuery, Vision, and the Google search. So that's actually our whole app end to end. But there is one last thing that I want to mention. Now, for those of you that have production or code running live in production, you know the thing that we all fear is the day when something goes wrong. Because when there is a problem, it can be hard to identify exactly what that problem is, particularly if you're running this application that's scaling across many cloud services. It's across split between different containers, whether it's App Engine or Kubernetes. It could be on a hybrid cloud with AWS and Google Cloud, or Azure and Google Cloud. It can make it difficult. And for that reason, we have a product called StackDriver. And so StackDriver provides us with a great toolkit, and it supports multiple clouds. Obviously deeply integrated into Google Cloud, but can also support capabilities across other cloud providers. So when it comes to monitoring or logging or debugging, it's all there for you. And I'm going to show you a quick demo of that right now.
The mic's back on.
So in this case, I am going to go, I'll just mark this as result. Okay, Google, talk to my test app. Okay, Google, talk to my test app.
Sure, here's the test version of my test app.
Good day, fellow developers.
Throw an exception.
My test app isn't responding right now. Try.
So basically,
The mic's off.
It's gone and thrown an exception. Whilst we're waiting for that error report to be generated, what I'm going to show you is logging. So with StackDriver, what we can do is go and have a look at our logs in real time. And I apologize that font is a little bit small. Let me make it bigger. What you'll notice is the time is 4:18. So we can see timestamps of when I've been doing my queries, each and every one of them. And you can see something like the requests that have been going on. We can actually select like the trace ID and then find all of the requests for that particular request response. We can look at some of those responses. So here, this one is clearly the BigQuery response that we got for the top Hacker News post, and you can see the fulfillment text said it scanned that many megabytes and so on. Like any good logging tool, you can see that we can actually filter based on the type of message that we have here as well. And you'll see that our error has shown up in the log. I'm now going to switch from logging to error reporting, where what we should see is our error that's shown up. And just to show you that that was something that wasn't pre-canned, you can see that it came up a minute ago. What I'm going to do is I'm going to click it. I'm going to click it. Because I've zoomed in, everything is a little bit bigger than I expect. And you'll see that it's told me that this exception has been thrown. We can go and create some issues around it. We can see how often it's been thrown. But here's the thing that as a developer I really appreciate. I get the stack trace, the full stack trace for it. And when I click the source file that it told me, it's going to take me to the debugger straight away, and it's going to bring up all of my source code. Now, I'm going to zoom out a little bit here because in a zoomed in mode, everything is getting a little bit squashed. but you'll notice that it's jumped into exception thrown handler. Here's the source file. If we just scan up to the top of the file, you'll see that it's our intent exception.throw, which is set up in Dialogflow, coming in, and we actually throw an exception. And so it's jumped directly to my line of code. Now you'll notice that it's been able to jump to my source code, even though this source code lives on GitHub. If you don't want to give access to StackDriver to your source control, or for whatever reason you can't, you can upload a local copy of your source code as well, so it's not necessarily working against the server. But the point is that even though this is a release build, we go to a great deal of effort to make sure that we can match your symbols to the exact line of code that it's thrown. So now that we know that there's an exception being thrown, that's great. But like when we have a problem in production, one, we go and find out what happened. Then we argue about the fact that, it could never happen. It could never get to that line of code. And we've all been there. We've done that. So the cool thing we can do in StackDriver is we can set a breakpoint. Now I'm going to throw another exception. And I want you to pay attention to the bottom right. It says waiting for snapshot to be hit. OK, Google, talk to my test app.
Sure, here's the test version of my test app.
Good day, fellow developers.
Throw an exception.
My test app isn't responding right now. Try.
I'm just muting it. It's going to come up in a second. Now, in a traditional debugger environment, when you set a breakpoint, it stops execution when it hits that line of code. In a production environment where you're trying to reproduce a problem and you just can't get it to happen, you don't want to stop execution when your production system is running. So what this does is actually it takes a snapshot, and usually it's instant, so I'm not sure why it hasn't hit it yet. We'll just give it a minute. Or actually, you know what? I'll try one more time and I'll set it outside of the switch statement.
The mic's back on.
Sorry about this. OK, Google, talk to my test app.
All right, getting the test version of my test app.
Good day, fellow developers.
Throw an exception.
My test app isn't responding right now.
There we go.
The mic's off.
I think it was because I did a breakpoint on case null, which it wasn't going to be. My point is, so we've come right in, and this is just like a traditional debugger. But the cool thing is that what StackDriver did was take a snapshot of your production code. And so we get our full stack trace. We have the full state of our application, so I can expand all the sort of fields and variables that we have, and I can dig right in to try and identify where things are going wrong. Now, when I set that breakpoint as well for the snapshot, I could have set conditions, so it didn't need to necessarily trigger. Maybe this particular problem happens when one of the variables is of value 15 or something, or greater than 15, and so we can put conditions in there as just standard expressions. And then you can see here on the right-hand side, I apologize for the wrapping. Whoops. I have clicked off it. I won't go ahead and reproduce it. I apologize. I had fat fingers and I hit the wrong button then. My point is that we had a stack trace on the right-hand side. I could have drilled up and down the stack and looked into exactly what was going wrong there. So snapshots are really, really awesome. And the other cool thing about snapshots is you don't have to just wait for them to trigger. What you can do is set up your snapshots, and then you can leave the system. Let's say it's 7 p.m., you've been working the whole day, you just can't reproduce this thing. Set up your snapshots, come in the morning. If one of those conditions has triggered, those snapshots will be recorded and waiting for you to go and analyze and then identify the issue. So StackDriver is super cool. I am biased. And the last thing I want to show you with StackDriver is tracing. So for that web page that we have, we use this long pole. So it's actually quite inefficient. Oops. Tracing. unfortunately, I'm just going to see what's going on here and change my zoom level back to 100. I'm not sure why it keeps jumping into the debugger. Maybe I need to clear out my snapshots. There we go. So with tracing, we're able to see operations that take too long. Now our web page, it's quite inefficient. So you can see that we have these long latencies for just polling that web page. But this /conversation endpoint, that's where Dialogflow is basically calling. Every time we speak to Google Home, it goes into conversation with the /conversation with a specific JSON request. And if we click conversation, we can see where it's taking so long. So you can see that the number of times that it's being called recently, broken down by timestamp. You can see exactly how long it took to respond to some of those. So if we have a look at this one, that was 7.5 seconds, which seems pretty long. And now let me try zooming in. Let's see how it handles that. You'll see that in our case, it's actually taking quite a long time for doing our Hacker News query for whatever reason. Now we can drill into that. We can look at the log. We can jump to source code from here and try and get to the nitty gritty. But the point is, just with our UI here, we can easily go and try to identify where our performance bottlenecks are. And with that, I'm going to switch back to the slides. To complete our diagram. So we had people talking to their devices through Google Assistant. Dialogflow is what was able to do that natural language processing and map to various parts of our application. We did a Google search that we could then query to Vision API to understand what was in there. We could also query BigQuery with some public data sets is what we used. And now we also have StackDriver in our image to go ahead and do things like logging and monitoring and error reporting, debugging, and tracing. Cool? With that, I want to thank you very much. I hope that this has been a fun little demo app, and I hope that this has been an informative session. The source code, I promised a short URL. Can everyone see that? Is anything blocking your way? It's on GitHub, and in the README, we've got the full set of instructions on how to deploy it. For someone that has no experience with the Google Cloud Platform, I still think it should take you about an hour at most to kind of get it going. Reach out to me on my Twitter handle if you need any help. I'll be happy to answer some questions. And one thing I just want to reiterate, we did look at App Engine Flexible today, but this particular demo can be deployed on Google Kubernetes Engine as well very easily, and the README describes how to do that. So I just want to say thank you, and I hope you enjoy the rest of NDC. Now we have a few minutes, so if you want to ask any questions, I'm happy to take them. I don't think there's a mic there, so either shout out or just come and see me at the front. Yes?
I wasn't really sure how you connected the application to the Dialogflow.
Very good question. So when you go into Dialogflow, Chrome just updated recently with this new user interface, and it turns out when you go into full screen mode, it actually hides tabs now, whereas I could see them before. Anyways, in Dialogflow, if you go into fulfillment, you have this webhook, and you basically point it to your server. So in App Engine, I've gone and deployed our .NET application, and I've deployed it to this anchor-.net.appspot.com, and there is an endpoint there that /conversation. So Dialogflow is basically, we're just pointing it at that, and then in the C# code, we're using the Dialogflow SDK. So there's some work to be done on this side of on your code side to take the SDK and set up the intents and so on. But that's the bit in Dialogflow that one line is the thing that points it to your backend.
And then the different intents then, do they map to different routes in the app?
Yeah, so in the app, if we look at, let's say, something like the vision search, where we're saying the first thing we do in this is to say, hey, show me pictures of Sydney. You'll notice we've annotated the top of the class with it says intent vision.search. And the vision.search is defined as an intent here. And so when you call vision.search, and I'll just click that intent, it basically it's when we're asking for various things. So in this, the examples we've put in is pictures of dogs, but it can substitute dogs with any search term. So it's extracting what that search term is, putting it into a, I'm sorry that's cut off, it's because of the zoom level, that says search term, but it puts it into that parameter, packages it up, and then because of the Dialogflow SDK, it'll call any class annotated with this, it'll call the handle async method, and then we're good to go. Yes?
How easy is it to deploy to our and could you in theory just use like your ecosystem to do like exactly?
Yeah, so actually one thing I didn't show you, so let me answer the second question before I answer the first one. In terms of deploying it to like your phone and so on, by using Dialogflow, we've actually deployed it to Google Assistant. So whether I talk to home, whether I talk to my phone, or if I go to the actions on Google Console, which I didn't show you, but like I can say here, talk to my test app, and I can type in all the same queries, and now it's running my test app. You can see up the top there, and I can do those same queries. So when it comes to like debugging and sort of developing your application, I suggest you start in the simulator, but as soon as you hit deploy, it's available across all the, in my case, I've only deployed it in my test environment. So anytime I'm talking to my Google devices, I'll be able to use this app. Right now, it's not published to the world.
So it's something like linked to your Google account?
Right now it is, but I can publish it to the world. The publishing process is separate though, and there is a review process and so on to make sure that we have the right things on the platform. What was the first part of your question that I didn't answer?
How you get it onto Google Home, but I think you kind of
Oh, okay, I answered both of them. Yep, sure. Cool, yes?
The Dialog Flow.
Yes.
Is it free for dev?
It's a good question. So, funnily enough, because I'm not on the sales side, I tend to just use this stuff without knowing the answers. I believe Dialogflow is free, but obviously App Engine is a paid service.
Okay.
So the Dialogflow, the conversational UI part, I believe is free. And I'll just make sure I'm not lying to you. Oh gosh, where is this? Dialogflow.com. Pricing. Maybe I'm lying. Okay, so there is an enterprise version of it, but I'm not gonna. I'll rather let you look at this because I'm not familiar with the pricing plan, so I don't want to comment incorrectly. There was someone here.
So like how you said, this is specific to your Google Home now.
Yes.
You haven't pushed it to public.
Yes.
Once you go public, then it's kind of an app for. Does it work like?
Yeah, it's ephemeral. So basically, and this is where the review process and so on comes in, because basically you give a command, like right now I say talk to my test app, which isn't how I'd publish it, right? So let's say I was a pizza place and I wanted to say, hey, order a pizza from Ankur's Pizza Place, like that's the namespace I wanted, then that's how people would engage with it. But the thing is, there is no installation. It's like the web, it's ephemeral. So the users would speak a command that launches your app, and it goes through the process, and then you can get out of it.
And that namespace is an intent again.
That namespace, I believe, is global.
It's global.
Yeah. Global with, I'll put a caveat in that there may be regional restrictions, like for an example, I don't know the answer to this, but I imagine that if I say I want to speak to Pizza Hut, I'd expect Pizza Hut Australia, not Pizza Hut US. But like, you won't be able to say, talk to Google Search and you'll have the Google Search namespace.
Now, with the fulfillment, you added one app URL, like so.
Yes.
Can we have multiple fulfillments or just one?
It's one per agent, so you can have multiple Dialogflow agents. So if sorry, I got to unfull screen just to select the tab, but you'll see on the left-hand side, I've got this agent that I call .NET agent. I can create multiple agents, and each of those agents will have their own fulfillment. Sorry, I'll get some other folks and then I'll come back to you.
Does it support multiple languages?
You mean like spoken languages? Yes, absolutely. I'm just thinking where it is. Oh, actually, it's right here. You can see EN. So you can add multiple languages to this, yes. I do believe that there is some level of translation that's provided as well, but if you want to, typically when you're talking about conversational agents, you want to inject a bit of personality. So like in my case, I said, "G'day, fellow developers." It's not going to say that out of the box. So if you want to localize it to other languages, you might want to inject a similar type of personality that's appropriate for that culture and language as well. Yeah. So like when you add multiple languages and you've got the phrases, you can switch languages for those phrases and so on. Yes. Yes. This one, I deployed it to. So in the case of this, I have deployed it to Sydney. So it's the App Engine instance that's running in Sydney. But when I look at the BigQuery public dataset that I was using, like that's a separate API that I'm calling, and that's a public dataset. That database doesn't live in Sydney. Dialogflow. Yeah. I'm not sure about Dialogflow in the sense that like Dialogflow, because it's an intermediate, it's working with Google Assistant. So Google Assistant isn't necessarily running in Sydney. Like it's going to find the one that's right for the user. But in terms of your application itself, like the App Engine piece, and if you're storing any data, you can specify which region and data center you're in. So the Dialogflow isn't storing any data about the user at that point. Yeah, that's true. So I don't know the answer to the Dialogflow piece, but I'm pretty certain that you don't declare which region the Dialogflow sits on. You definitely can declare the region for App Engine and BigQuery and so on. Yeah. So cast integration, like there is a cast SDK, and so you can cast to Google Cast devices. I'm not sure what you're talking about with this. I know with Google Home, like not your application, but with the standard Google Home functionality, you can say, hey, play Coldplay on my bedroom speakers or something. In terms of you making that linkage, I don't believe we have a server-side cast SDK. I think the cast SDK that we publish is for Android, iOS, and maybe the web, but not a server-side one that I know of. Yes? The very bare minimum, if you can get away, if you wanted to do something like a quiz or like a choose your own adventure story or something, you could do that entirely in Dialogflow. You don't need any of the App Engine pieces and so on. So there you're just basically creating a hierarchy of different intents. And one thing I didn't go into actually, I'll quickly show you now, is that when we first get into our app, it calls the default welcome intent. And then the user can choose to go into vision.intro or BigQuery.intro. And then from there, BigQuery.intro can go into Hacker News or AA Extreme. That's the temperature thing. So there is a hierarchy of intents that you can have, and you can go up and down those hierarchies. But you can create an entire conversation app entirely in Dialogflow. In our case, we were doing some sophisticated things. We were fetching images from Google Search. We were calling the Vision API, and that's not. You can't really write code in Dialogflow here. That's code that we were executing that was very much in our App Engine instance. Sorry, could you speak louder?
If I have a public facing API,
yep.
different cloud, and I want to hook something from that, so does that mean I need to have a container running in the Google Cloud, which talks to my API, or?
No, I mean Dialogflow, if you looked at that fulfillment thing, it was calling my domain/conversation. And so it's basically sending JSON requests and expecting JSON responses. So as long as you adhered to those standards, and you probably need to handle some OAuth authentication and so on, you could probably get away with it. But the Dialogflow client libraries that we have are make all of that easier for you. Now this code that we've built, I don't believe you have to run the actual App Engine code. You don't actually have to run it on App Engine because it's a C# .NET container, And as long as you can deploy that container on whichever server that you want, whether it's on-premise or somebody else's, you could do that. Yes?
Is the namespace that you're looking at in Dialogflow,
you know what? I haven't actually published my own voice app. I've gone to the state of like developing stuff here and then stayed in my sandbox. I do know that that there is a review process, and I don't want to speak to that because I'm not familiar with that side of it. I'm more familiar with developing with it rather than publishing with it.
okay, even for the development part, what makes test app Dialogflow?
Oh, so when you go to, I'm just going to bring up an incognito window. When you go to dialogflow.com, oh, sorry, console.dialogflow.com, so I'm going to go to console, it asks you to sign in, right? Coming up. There. And so at that point, when I sign in, and then I deploy my agents, like I enable them, it's deploying them against the Google account that I've signed in with.
Yeah, but you could have multiple apps. Like what makes test app in this particular?
That's a good point. I think basically you have a way of enabling and selecting which is the current live test app, so to speak. Yeah. All right, lots of questions, great. Anything else? No? All right, enjoy the rest of NDC. Thank you so much.